Okay, this is going to be a start of your notes for section 6-1. And there's a handout that you'll be getting after going over these first two problems. I'd like you to practice those and bring those in on Tuesday, and I'd like to go over them at that point. This will be another practice sheet you get later. This is 6-1, the law of signs. If at any time you need to see a page of notes for a longer period of time, you can have someone push the pause button and then go back and look at that. The objectives for this lesson are listed here. The one that we're going to use today is using the law of sines to solve oblique triangles using angle-angle side situations or angle-side-angle situations. Next week, we'll look at those other parts of the objective using the law of sines to solve oblique triangles with the side-side angle situation, as you know, might cause us problems because it's kind of that naughty word backwards. And we'll handle that next week, and then find the areas of oblique triangles and use the law of sines to model and solve real-life problems. This is our introduction, just a little piece of information. An oblique triangle is simply a triangle that has no right angles. Standard notation, another thing you just want to be aware of, angles are labeled with capital letters A, B, and C, and sides opposite the angle are labeled with lowercase letters of A, B, and C. So for instance, if we call that capital A as angle A, then side A is the side that is directly opposite that. And so to solve an oblique triangle, you need to know at least one side and any two other measures of the triangle, either two sides, two angles, or an angle and a side. And then here's a breakdown of the four cases. As I said, today you'll just be looking at the two angles and any side, angle, angle, side situation, or angle, side, angle. And I'll just leave the rest of those. This is the one that's going to give you a little bit of trouble next week, and we'll be looking at that. And then this next slide gives you the law of sines. You should probably already be familiar with the law of sines. Just a reminder, you're usually setting up that proportion with any two fractional parts, and also below here that the law of sines can be written kind of in that other way as well. And we have just two situations shown of pictures of triangles. You might want to pause right now so that you can write the law of sines and then move on. The next thing we're going to do is this first problem. You might want to take a moment and even pause again here and draw this picture. It is the example in the book, and I'll be going over that one today. I'll just say what it is. That'll give you a little bit of time to write it down. Angle C is 102 degrees. Make sure your calculator is set in degrees for this little part. And angle B is 29 degrees. And side B is 28 feet, and you're to find the remaining angle and sides. And if you look at the way this triangle is marked, you would consider that angle, angle, side. So there's an angle of 29, an angle of 102, and then the side of 28 that follows as you go around the triangle. So the first thing, and probably easiest thing in this situation, is to find that missing angle. And so A is going to just equal 180 minus the sum of the other two angles, 102 plus 29. And so that's 180 minus 131. And so that means that A is equal to 49 degrees. So that part was pretty easy. Then using the law of sines, whichever version of that you find most convenient, I'll slide this up a little bit so that it's just easier for me to see what I'm going to be working on. And then I start usually with the law of sines using a side and an angle pair where I know both of those. In this case, I can use the given information. Some of our other cases we'll have to use like the angle that we found or some piece of information that we found to find other pieces. So I'm going to set this up as 28 over the sine of 29 degrees equals little a over the sine of 49 degrees. Cross multiplying and then dividing, I get little a equals 28 sine of 49 degrees divided by sine of 29 degrees. And then that gives me on the calculator, you can kind of check that, that A is approximately 43.59, and we'll label that in feet as it was before. And then I'll just go through that same process to find the missing side C. And so for that one, I'll just stay with my 28 over the sine of 29 degrees. And that's equal to C over the sine of 102 degrees. Cross multiplying again, I get C equals 28 sine 102 degrees divided by sine of 29 degrees. Maybe take a moment for that one, type it in your calculator and see what you get. And you should have found maybe that you have 56.49 feet. And so we've found all three missing parts on this triangle using the law of sines. The next couple slides show this worked out as well, and that will be on my Yola site later on, and you can kind of follow that as well. I will just go through those slides kind of quickly to get to example 2. For example 2, we have a similar situation, and on this one, it's kind of a little bit of a word problem, kind of a interesting take the book has on this. This is looks like a telephone pole, and it is tipped toward the sun at 8-degree angle, so it's evidently not at a 90-degree angle with the ground there. And it tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees, and then we want to figure out how tall that pole is. Hopefully you're not hearing too much static. I had to just adjust my headphones. So this is our situation for this one, and here we have that angle B is then 98 degrees. I'm going to maybe write that down. Capital B is 98 degrees. Capital A is 43 degrees. And then little c is 22, just to kind of validate what's given in that particular picture. So the first thing that I'm going to find is capital C. So capital C is equal to 180 minus 98 plus 43. I have those in parentheses. So that's 180 minus 141. So capital C is 39 degrees. And then really I'm not asked to find all the parts. I simply have to find the height of that telephone pole. So I only need to find the side that's little a. And so I'm going to set up my law of sines ratio as 22 over the sine of 39 degrees equals little a, over the sine of 43 degrees. Cross multiplying, I get a equals 22 sine 43 degrees divided by the sine of 39 degrees. Take a minute and see what you get for that height of that telephone pole. And if you took a moment to do that, you should have gotten 23.84 feet is the height of that pole from using the law of sines. That's the only two problems I want you to do. I just want you to refresh your memory, or that I want to do in the notes. I want you to refresh your memory of how to use the law of sines, and then we'll do that ambiguous case next week on Tuesday. You should be getting a handout that has these two problems on it. One is just find all the parts that are missing on that triangle, and number two, kind of to find the height of the tree, which evidently is not perpendicular to the ground either. And so I'll give you some time to work on that. If you finish it today and want to turn it into your folder, I'll look at it in the morning or on Monday when we as teachers are here and you are not. And then we'll move on Tuesday. And so on Tuesday, we'll be doing the ambiguous case, which of course is that, naughty word backwards. You might want to think about what that entailed when we did that in geometry. Enjoy your weekend. I will have your tests and everything corrected on Tuesday when you get back. You might want to check your the grade book at some point this weekend. I'll probably have that done.